We're going to jump right in here. These are the three definitions of sine, cosine, and tangent. Okay, where the angle is here in red. X and Y are the coordinates of the point on the unit circle. So X is a little bit to the left, Y is almost all the way up to 1 for this particular picture. Alright, sine is Y, cosine is X, tangent is Y over X. Now in class I tried to get you guys to kind of discover these two on your own by playing around with the calculator and the unit circle. And then it turns out the tangent is actually Y over X. Now let's actually kind of try to explore Y a little bit. If we have, and I should have put this in beforehand, but let's say we have a radius of 1. Alright, which is the case here in the unit circle. Radius is 1. That's something you have to keep track of, so I'll put it right here. Alright. If you have a right triangle here, so this is the 30, 60, 90 triangle. I'm just using this one because it's convenient on the picture here. Alright. Remember what sine is. Sine is opposite over hypotenuse. So the y coordinate over 1. Y over 1. Sine is y over 1. Alright? So that's exactly like SOHCAHTOA between 0 and 90 degrees. Here's y, up and down. Here's the hypotenuse of 1. Sine is y over 1. Cosine is adjacent over hypotenuse, so it would be the x coordinate over 1. Alright? And then tangent is opposite over adjacent, so it is the y coordinate over the x coordinate. So these things come from SOHCAHTOA, only now you can make it, well, any angle. Alright? So if you draw the little straight line going down, you can see it's, well, sine of y, or sine of theta is the y over the radius. It's still the radius would be 1, so the hypotenuse is the radius. They're one and the same here in the unit circle. It's y over 1. Okay? Cosine is the x coordinate over 1. Alright? Now it's adjacent over hypotenuse, or the x coordinate over the radius. They're the same kinda, except here the x coordinate would be negative. Okay, and then tangent is the y coordinate, which is opposite, over the x coordinate, which is adjacent. You might want to watch this again to try to fully grasp it, because there's a lot that I just said in about 3 minutes. Alright, but these are the takeaway. What you should make sure to understand here is that the y coordinate is sine, the x coordinate is cosine, and if you take the y coordinate over the x coordinate, that's tangent. Alright? And the coordinates are always points on the unit circle. So for instance, we have these 4 corner points that I marked. Okay. Up here, so sine of, let's say, 110 degrees roughly, okay, should be the y coordinate, so almost 1. So if you put that in your calculator, you should get almost 1. In fact, you get 0.94. Okay. Cosine is pretty small. I would say roughly a third. In fact, we can kind of check that out. Boom, boom. That's roughly a third. And there you go. 0.34. That's roughly a third. It's pretty close. Okay. But wait, why is it negative? Because it's going to the left. Okay, and last but not least, if you take the y coordinate over the x coordinate, it's like 0.9 over 0.3 and change, negative, you get this. So I would pause right now and make sure that this is what you get in your calculator, and verify that yeah, it's the same thing. So one thing you guys will have to do over and over and over again is to find what are called exact values of trig ratios. Now it's exact values if it is, not some decimal that is rounded off. All right, and when we see exact values, it is almost, well, on occasion it will be an integer, but mostly it is a fraction. Okay, often involving radicals. So if I see decimals, if I want the exact value of, oh, let's say sine of 300, okay, because that's the one I'm going to do here, and I see a decimal, I'm going to know you just use your calculator. This may seem a little silly because some calculators will just find these exact values for you, but I want you to be able to walk through and do it, you know, with your brain. All right. The fact that the calculator can do it is not really the point. All right. So steps for finding exact values of trig ratios. So let's do it for this one. Sine of 300. All right. So 300 degrees is, starts around here, it goes around most of the way around, boom. So here is, hold on, I'm going to pause it. Alright, so sine of 300 degrees, 90, 180, 270, boom, to 300 degrees. Okay? And so what we have here, it looks to be a special right triangle. It looks to be a, well, it's hard to tell, maybe, if you're not used to doing this. But this looks like this one right here. It looks like this guy, oops, this special right triangle here, except upside down. Alright? It's not lining up totally perfect. There we go. Okay? So this looks like a 30, 60, 90 triangle where here's the 60 right here. Okay? We want the y coordinate. Okay, we want the opposite side for a 30, 60, 90 right triangle. So remember how we did it in class? This is the hypotenuse is 1, the short side must be a half, and the long side must be root 3 over 2. I need to get a regular. So this is, the side length is root 3 over 2. Okay? Now, I kind of skipped a step in here. Okay, I mean I did it here. Determine the side lengths. I probably could have made step 3 determining what this angle is right here. This angle right here is, well, 60 specifically. This is called the reference angle. The reference angle. Okay, that's 60 degrees. Okay, it's the acute angle that the terminal side makes with the x-axis, the acute angle. Okay? So the fact that the reference angle is a 60-degree angle tells us which special right triangle it is. Okay, and then we can determine that this opposite side, which is what we care about, because it's sine, okay, and then so the side length is root 3 over 2, which means that this is negative root 3 over 2. Okay? Let's do another one. Or another several. Alright, so cosine of 5 pi over 4. So, oh no. So 5 pi over 4. So you got to count, you got to figure out what 5 pi over 4 is. If you have the acute angles kind of memorized, you can sort of walk through what the big ones are, the bigger angles are. If you have these acute angles memorized, namely in this case that this is pi over 4, then you can kind of figure out where 5 pi over 4 is on the line. So this is 0 pi over 4 here at the origin. Or not at the origin, but you know, with no movement, 0. This is 1 pi over 4. This is 2 pi over 4 right here. So I'm going another 45 degrees if we want to talk about in terms of degrees. 3 pi over 4, 4 pi over 4, and 5 pi over 4. So there we go. This is the reference, or the angle that we want. Okay? And that's good, but not bad. Alright, there we go. Okay, so this is the angle that we're interested in. So cosine of 5 pi over 4. So we draw the little right triangle. Okay. That's horrible. Alright, so we draw the triangle. Slightly better. Alright, and this is got to be a 45, 45, 90 right triangle. So our side lengths are root 2 over 2 and root 2 over 2. Now actually I only care about the horizontal one. Okay. This is root 2 over 2. Why? Because this is the x-coordinate. That will give us this x-coordinate. Okay, so the x-coordinate is root 2 over 2. Or excuse me, no it's not. The side length is root 2 over 2. Since we're heading to the left, that means the coordinate right here is negative root 2 over 2. Because we've gone to the left. You know, this x-coordinate at this point right here, I'm making it huge, is negative root 2 over 2. Alright. Tangent is negative 750. So that means we got to go, and I'll change colors to designate the fact that it's negative. We got to run once, twice, that's 720, and another 30 degrees. So here we go. We are at negative 750. And let me back that up here. Negative 750. This guy right here. So this appears to be a 30, 60, 90 right triangle. The acute angle, the reference angle, by the way, the reference angle over here was the 45 degrees. It's the acute angle that the terminal side, so that's the diagonal guy, makes with the x-axis. The acute angle that the terminal side makes with the x-axis is 30 degrees here. Okay, it's the little one. Remember, 30, 45, 60. Alright, so that means that, well, we actually need both of them here. 1/2. And then this is, see if I can draw it relatively straight, actually not bad, root 3 over 2. Okay, so we have our reference angle of 30 degrees, so we go straight towards the x-axis. Okay. And so our y over x is a half, negative, over root 3 over 2. I'm going to the right, so that's positive. So this is super duper unsimplified. We would never leave it like that. So how you could rewrite this, and this will be to the point where you kind of memorize what these are just naturally. But here's something that would always happen. These over 2's cancel out. Think of it this way. I don't know which way is best to think of it. But if you find it helpful, if you multiply this fraction by 2 over 2, all the 2's cancel. So you're just left with negative 1 over root 3, which is mathematically fine, but that's usually not how you see this answer. If you rationalize this denominator, alright, and we'll talk a little bit about how to do this in class, you would get, or we'll definitely talk about how to do this in class, negative root 3 over 3. Alright, that's how you would see it in, oops, let's just not do that at all. Negative root 3 over 3. Go away. Alright. So there we go. That's the actual answer. Okay. So what if they do not end up off on a diagonal, or one of the special triangles over here on one of the 4 quadrants here, quadrant 1, 2, 3, 4. What if they end up not a diagonal angle, not a diagonal terminal side, I should say. That's what I'm trying to get at. What if you get something like this? 180 degrees ends up right there. So the terminal side would be this guy over straight to the left, if I could draw it. So here's 180 degrees, a straight angle. Alright, what are the coordinates? Well, the coordinates right here would be negative 1, 0. So the answer is just 0. Y coordinate is 0. Alright, remember what the sign is. It's the y coordinate of the point out here on the surface of the unit circle. So there you go. This guy does this. And then the coordinates here is 1, 0. So remember, cosine, we're dealing cosine is x coordinate, so the answer is 1. Alright, so there you go. We'll of course do more of these in class, but hopefully this gets you a good head start.